Maybe I have to tell the secret. Well, Blue Jean started as supposed to be a donation from IBM to DOST. However, we were impressed. They impressed on us that there were problems if it were a donation. And so they charged us a very friendly fee of $10,000 for the entire Blue Jean. But we were told that Blue Jean cost about millions. Yes. So, but they charged us only $10,000.
Okay.
So in terms of the preparation,
for the maintenance, we have requested UP to help with the maintenance. We are also looking into a sustainable mechanism whereby all projects that will be using the machine, whenever they ask budget from DOST, they will have to put in their line item budget the fee that they will pay the facility. So in a way, it will be both UP and DOST that will be ensuring that it will be maintained, the facility will be maintained in the future.
may I also follow up a question? Aside from the programs that you mentioned that will be using or utilizing the supercomputer, will this be open to other government offices or even other schools that could use the...
Yes. The Philippine Genome Center was established within the UP system. But when we convinced DOST to support us, we promised DOST, I was with UP then at that time, we promised DOST that this will be a facility for all government research institutions, as well as public, as well as private institutions. So, however, in order to maintain it, we will have to charge a minimum fee for the use of the DNA sequencing as well as the biometric sequencing. So it's open for everybody. In fact, the plan of the Philippine Genome Center is that once they have established the facility, we can even open the market to our neighboring countries.
To provide higher value.
Good afternoon. I'm Joel Gana from online cyber media with this SIDEM. Although I read a lot of background before coming over here, but I want to hear directly from you. What exactly makes a supercomputer, and what's the advantage of a supercomputer from a powerful computer, and then how do you exactly maintain that term supercomputer, considering there's a rapid upgrade in the technology? And secondly is, what advantage does a IBM supercomputer have over the other supercomputers? Thank you.
So there's a broad category called technical computing, and supercomputer is really a subset of that. Technical computing has to do with the scientific kind of processing that we're talking about here, whether it's genomics or whether it's weather modeling or whether it's seismic or all very technical computing, usually measured in the number of flops or the floating point operations per second. Supercomputers are built to do that really, really well. And so one of the advantages of something like this, you saw the number of cores, is also the interconnect and how quickly you can move data in between those cores. So as you can imagine, to get all of those 4,096 cores operating in synchrony, you have to do a lot of things to make that parallel type processing possible. There's a lot of debate about what qualifies something to be a supercomputer or not a supercomputer. It's a very subjective term, but you can actually go out and see the list of the top performing supercomputers, usually measured in the number of teraflops and petaflop capabilities that are out there. So, Guru, I don't know if you wanted to add anything to that. Okay. Wow, not bad for not a fellow, right? So ours, you know, the things that I think make ours better is actually a lot to do with the interconnect capabilities. A lot of the breakthrough processing in our case is about the interconnect, the network connection inside the machine. Don't think of it as an outside network connection, but an inside connection. So the interconnect fabric that connects all of those cores together is really what makes the supercomputer special, and an IBM even more so.
Tom, if I may add also, that what makes IBM special is the power efficiency. You can connect computers together. You can you can create a so-called supercomputer. But what makes Blue Gene stand out is its power efficiency.
It's not just about the hardware. While hardware can be built and innovatively be built, it is about the tools and being able to provide the applications that run on that and being able to optimize to that. That's the reason why IBM is one of the leaders in this area.
I am Jayan Tuazan from Interaction.com. In relation to that, can you give a bit more of a tangible figure as to how much data the Blue Gene can process? Like for 1 minute, for example, like how much data?
It's not so much, as Tom pointed out, the capacity of a supercomputer is typically measured in the number of flops. And I believe that the starting configuration that Philippines is getting was 13.9 petaflops. I'm sorry, teraflops. Yes.
What does that mean?
Yeah, can you give a more equivalent, more down to earth?
Millions of floating points operations is flops, megaflops. And the one beyond that is the teraflops 10 to the 3, and the one beyond that is petaflops. So it is.
I'll try. A floating point operation is different from, say, a banking transaction where you're only talking about 2 decimal points for the degree of accuracy that you need. So floating point operations are typically more difficult because you need to be highly accurate. If you're multiplying numbers together, you don't want to have any kind of inaccuracy in the data. I don't know if you wanted to add to that.
So by definition, just to clarify and support what Guru and Tom mentioned, so it's how many floating point operations per second. So to translate it very loosely, it's like the speed. The Blue Gene that the Philippines will be getting is 13.9 teraflops. So that's 10 to the 12 power. So 13 per second. Floating operations per second. So in terms of speed, that's pretty significant.
So how does that relate to the commercial type of system?
So commercial workloads don't typically have to do floating point operations because you don't, as I said, you don't have the degree of accuracy that you need. Many decimal points worth of accuracy in a floating point operation. Banking transactions, as I said, would only be 2 decimal points at most, right?
That's right. Yeah. So for example, when you do weather simulation, Dr. Gay and Dr. Jerry actually showed some of the equations that come into play for weather forecasting. You could run it on a multi-core computer that you have, a commodity multi-computer, and it could either hang your computer or it could run for days, and you're not yet finished simulating a 7-day forecast or a 2-week forecast. With a supercomputer, it could be much faster than that. And we hope it to be more relevant.
So in simpler terms, it's more accurate and faster.
For this kind of data, for this kind of number crunching that it's got to do.
But,
That's why it's called technical computing.
How does it compare with previous IBM supercomputers like Watson and Deep Blue, for example?
So Watson, as an example, isn't really a supercomputer. Watson is a commercially available Power 7 computer, one of the ones in my stable of systems. The Watson system was built out of commercially available Power 7 capabilities. It was done with thousands of cores. It was also done with all in memory. So everything was in what's called RAM. So it was all built with 16 terabytes of RAM memory. So we didn't have any time in that particular application to go out and do any I/O. We didn't have time to do any reads. So it had to be all done within, in that specific example, within 3 seconds. There could be other examples where it doesn't have to do that, but in this specific example, it had to be done all in memory. The reason we chose the Power 7 technology is a couple. One is for those of you that know technology, is the speed of the thread. So it's got dramatic capabilities to do multi-threading and very strong threads. And the second is the speed between memory and processor. So if you think about it, even though it's all in memory, how quick does it take for me to get from memory into the processor and back out again? So the speed of memory is what makes Power such a good analytics capability for commercial workloads as well.
We have time for 2 more questions.
2 questions, please.
Fight your way to the front.
Are there a lot of these machines, supercomputers in Southeast Asia? Is the first in the region, and how many of
Only one in Southeast Asia? Only one in Southeast Asia.
in Asia?
No, Southeast
In
Asia.
Asia? But in Asia also?
No, there's others. India, China.
India, China.
And then the Philippines?
Japan certainly has computers.
And the last question is, can you explain how the supercomputing capacity, capability, in a layman's language, is able to run a space station, for example? Or what level?
Dr. Rao.
I think Dr. Sabido already pointed out, as Tom was pointing out, when you go to the bank or when you want to get money from the bank, you're getting a limited amount of data and you want it very, very fast. But on the other hand, when you're trying to predict weather, what you have to do, as one of the pictures showed earlier, you have to define a very large complex grid and associate how there is data that pertains to that at each point in the grid. So it is a lot of data, and it has to be done in parallel, and it has to be done in a reasonable amount of time. Otherwise, people will have to wait for weeks or months. So in layman's terms, it is being able to take very complex calculations, or projects that require very complex calculations, and bring the results with adequate accuracy in human terms, reasonable times.
Thank you, Yanni. For the last question, please.
With the camera.
Yanni Romero from Local 98. For the UST first, could you provide the timeline? You've mentioned that we're reducing the prediction from, kasi right now, 7 days po sir, no? 3 days to 7 days. Tama yun. So, we're increasing yung day of prediction for the weather and climate change so that it will impact community first resilience and climate change adaptation. How will the Project NOAA tie up with a partnership with IBM right now? And aside from harnessing the supercomputing power po, could you provide also a timeline for the Genome project in accordance with what Ms. Amy presented earlier? And for IBM, what's the long-term commitment of IBM for HPC projects like this? As well as for UP, what's the road 5 years, 10 years from now? Because we're creating roadmaps like for the Smarter Philippines, we have a 2020 project. Is IBM also part of the 2020 project moving forward?
First of all, let's talk about the weather forecasting. We extend the weather forecasting from 3 days, at present is currently, to 7 days. But we have even a more accurate forecasting. It will be more detailed, meaning the resolution is more detailed. It will be area specific. That's for the weather. But even more important is the season forecasting. 6 months is very important for the agri. What's the next season? I mean, we always talk about dry season and wet season, but it's not changing. so the change can be forecast, can be predicted. And also for climate change scenarios, which is years, maybe 5 years, 10 years, for us to prepare for adaptation. About for the genome, okay, I'd like to go to genome because of all of these facilities, we are looking at genome technology for so many applications, even the lowly tahong markers. We are looking at DNA markers to get the best variety. So even the masters, the seaweeds, we are looking at everything to get the best variety. It should be based on DNA marker to get the variety, quality, disease resistance, and so many other attributes. That can be possible because of the genome program. That also goes for animals, for trees, for not only humans. It enables so many applications that will really benefit in many areas. Maybe can add
You were asking the timeline. Yes, we are ready to roll out this year the first product of the Philippine Genome Center, which is the diagnostic kit for dengue. Okay. We conducted this research even before the core facilities were established by sending samples abroad for analysis. We have a number of diagnostic developments that are in the pipeline. This has been funded by DOST. Diagnostic kits, as I mentioned a while ago, for infectives, as well as varietal improvement, and we have funded the varietal improvement for abaca to make it bunch-up resistant, as well as maintain the strength of the fiber. We are very excited to hopefully start this year our genome project on coconut. Coconut is a crop that involves about 25 million Filipinos, about 69 provinces out of the 75 provinces in the country produce coconut. So you can just imagine the impact. So we are also coming up with varieties that are high yielding, early fruiting, and disease resistant. And we're starting that this year. For livestock and fisheries, we also have started all this. We have allocated funds starting last year. So we hope to get results in 2-3 years' time. For the medical applications, one of an area where we are all very excited about is the personalized medicine, and we target that within 3 years. We should be at a point where we can now apply personalized medicine here in the Philippines.
For IBM,
at this point, the commitment we have with the high performance computing is to support it for 3 years. So very much in alignment with the milestone, that Doctor had mentioned, primarily in very specific projects. But our commitment in our partnership with research and development is not limited. It's ongoing in terms of where we see the next generation will be. Regarding our participation in Smarter Philippines, I think you had heard that Mr. Rosamillia had mentioned about the Smarter Planet Agenda, which IBM had fully immersed globally, and we very much embrace the progress that we've had so far in country. That's why Davao became the very first Intelligent Operations Center, the first in the world for public safety and security because of our involvement with Davao. So we're very delighted to be part of Smarter Philippines, and based on what we're doing, we are engaged in multiple capacities. Smarter education, you'll hear a little bit more about that towards the end of the year around analytics. So, yes, smarter Philippines, smarter planet is hand in hand.
And the role of UP here is to provide the physical facilities and the intellectual resources, to do all the projects that are in the agenda of DOST. We're about to start construction of the Philippine Genome Center. I've already gotten the money to build the building for that.
How much?
Well, initially the first phase will cost us 150 million pesos.
How much is the total cost needed to build genome center?
Well, that's the initial phase, 150 million, but that's just for the building, pesos, yeah. Just for the building. But there are also, but that's just the nerve center, you know, because the research will be done in all the other existing research institutes of the university. You know, Marine Science Institute, National Institute of Molecular Biology, you have College of Agriculture, you have the College of Fisheries and Ocean Sciences in the Visayas. So all the campuses of the university and the scientists and faculty members of these campuses will be involved in delivering the research demanded of us, and there will be what USEC Ami calls the unified or harmonized research agenda of the country.
And may I invite the Commer Guru for any final words before we wrap up the session.
No, I would just like to thank everyone for coming, and I think you can see the partnership here, as I mentioned, between academia, between the government, and between IBM, something we stress. It has worked out really well for us. We've worked with many universities around curriculum, and I know that here we're working around business analytics as a key area around curriculum. This is something that we're just in the beginnings of. We heard several of the speakers mention big data, and again, it's kind of subjective of how big is big, but the degree of the variety of the data that we're processing these days, the velocity of the data, the volume of the data, and even the veracity of the data, the truthfulness, how much is in the signal-to-noise ratio is tremendous, and it's growing every day. And so we see a tremendous opportunity and challenge with all the data that's out there now, the things we can learn, things we can know, and how all of that can be applied, whether it be scientifically for the betterment of weather prediction or mudslide prediction, or whether it be commercially to help people to do smarter marketing and smarter commerce as you get individual and customized mailings to you about the place you are in your life. So there's so many applications of big data that I think it's, the world is just incredible, is on the beginning of something quite incredible here. And analytics, as Mariels has really done a great job here locally, she's made analytics to be a key part of the Philippines agenda for IBM. And so as you do more around business process outsourcing and getting more analytics into the curriculum of the universities and having people come out with the knowledge of how to analyze all of that data, I think it'll be a tremendous success in the future. We've been here for 76 years now. IBM is 101 years old. This year we celebrated our 100th anniversary. We do plan to be around for another 100. Time will tell. Most companies that have been around this long are oil and gas and sometimes mineral kind of companies, things that typically come out of the ground. In order to be in the technology space for this long, you have to constantly and continuously reinvent yourself. So we keep moving into the higher value spaces and making sure that we can continue to innovate and invest in R&D, invest in one of the, I would think, the top research organization in the world with 5 Nobel laureates in our midst, with about 80 or so fellows in the world, the top technical talent. We recognized a long time ago that it really pays for us to invest in technologists and scientists and not make them become managers in order for them to get ahead in life. And so we've created this program around dual tracks. This is really our commitment to the science, to the technology, to engineering, to math, and I really applaud the group here. The panel has shown you what's possible with all of that. So IBM is firmly committed to the Philippines, and we show that every day with the team that's here on the ground. I thank you for allowing me to visit and spend a little bit of time with you, and it's been a great trip so far. I don't know what else Mariels has in store.
It's first time.
My first time here. It's also my first trip in the new job, so first place I went was right here. So.
Thank you.
We're
Thank you
in
again.
favor.
Thank you very much, Tom. I'd like to invite Secretary Montejo for any final words.
Actually, earlier I was asking Dr. Rao that spend some time, a few minutes after, because this is really a milestone. This is the first time that we'll have a supercomputer, and this is the first time that we will be using this to process data, to useful information. So this is also first in the Philippines. First thing, it's a pioneering. We have a good idea how to use it, but definitely we like to request some guidance for other applications, or if what we are thinking is really best practice. That's what I was saying. So earlier we were discussing about high performance computing, and ASTI has one. 4 years ago it was new. Right now it's overbooked. Before the supercomputer was being discussed maybe 1 year ago, the issue was, can we utilize it 100% because the utility cost is also substantial. That was the issue less than a year ago. Now it's almost maybe 80% fully booked. Even it still has to arrive, but the number of users maybe in 1 year, 2 years time it will be fully booked. We will be requesting for another.
We have upgrades.
Okay, maybe we're requesting for another upgrade. That is how properly used technology using this equipment can be. The utilization can really ramp up. We have seen this with the genome. It really ramp up. It started with a good roadmap, good start. It really ramp up beyond expectation. Even the use of DNA is really very, very remarkable. So we are very excited about this development milestone. Thank you.